Hi there, Mr. Sutton here, bringing you the IM3 Honors 6-6 Extra Practice Number 5 Solutions on Solving Rational Equations. There is a puzzle that goes with this one. Let's see what that puzzle has in store for us. All right, without further ado, here is the puzzle that we're going to be tackling. We're trying to solve the riddle, what sound did the sheep hear when her sister exploded? Well, that sounds kind of violent. To solve this one, we have to solve these equations. And then when we get the answer or answers, we have to cross out the box that contains those. And one thing you're going to want to be careful about is some of these may contain extraneous solutions that you have to double check and eliminate after you've already solved the problem. So let's see what fun we have in store and get going on this. All right, so here's our opening problem. For all these problems, I'm going to be using more or less the same strategy, which is to figure out the LCD and multiply all the numerators by that so that I can get rid of all the denominators and just solve this as a regular kind of polynomial equation. Now, in order to find the LCD on a lot of these, you're going to have to factor in the very beginning. This one's no exception. So taking a look here at this lower right fraction, we've got things that multiply to 12 and add up to 7. So that's going to be not 1 and 12, not 2 and 6, 3 and 4 works, x plus 3, x plus 4. So my LCD then, this is going to have everything I need to cancel out all the denominators. So we definitely need the x plus 3 and the x plus 4. And as it happens, that also covers the other two denominators. So let me go ahead and multiply all my numerators by this expression now. So the 2 gets multiplied by all of that. Same with the 3 and the 7. Okay, so x plus 3's canceling out in the first one. Then the x plus 4's cancel, and then the x plus 3 and the x plus 4 both canceling there. Let's go back and see what's left over now. We have a 2 getting distributed. That's 2x plus 8. Next up, we have an x plus 3 with a 3 being distributed back here. So 3x plus 9. And then finally over here, we just have equals 7. Cleaning up my left side a bit, I have 2 and 3x gives me 5x. 8 and 9 gives me a plus 17. If I subtract 17, that's going to be negative 10 over there. And then dividing by 5, we get x equals negative 2. Now, at all the problems here, at the end of all these, you do need to double check and make sure that whatever x value you got, when you plug it back into the original or the factored version of the original, you want to make sure you're not getting 0 in any of your denominators, because that would be undefined, and then you'd have to cross off your answer as an extraneous solution, and it would no longer count. Now, if we plug negative 2 in, negative 2 plus 3, negative 2 plus 4, none of that's going to give me any zeros down here, so this answer is good. And let me look for it down below now. That's going to go with the KO right here, so let's cross that one out. It is knocked out, and we're on to the next. All right, for this next problem, just like before, I'm going to start by doing a little factoring to see what my common factors are. So everything's good except for this lower right denominator. Numbers that multiply to negative 10 and add up to negative 3. 1 and 10 doesn't work, but 2 and 5 does. Positive 2, negative 5. So my LCD has an x plus 2 and an x minus 5, and that covers everything else that we have in those denominators as well. So multiplying each of these by x plus 2, x minus 5. So the 4 gets multiplied by that, along with the 1 and the 2x plus 7, which I'm going to put in a parentheses just so I don't lose anything. Going back here, the x minus 5's are canceling, and then these x plus 2's in the middle fraction, and then both factors in the last fraction there. Picking up the pieces, we have 4 distributed here, giving us 4x plus 8. And then over here, the 1 gets distributed, so that's just x minus 5. And then finally, this 2x plus 7 is all that's left over on the other side of that equals. Taking the left side and simplifying a bit, 4x and x gives me a 5x, and then 8 minus 5 gives me a 3. My 2x plus 7 hasn't changed. Let me move my x's over to the left and my other numbers over to the right now. 5x minus 2x gives me a 3x over on the left. And 7 minus 3 gives me a 4 over on the right. Dividing by 3, we have x equals 4/3. And if I plug that back in up here, there's no way I'm getting 0 in any of my denominators, so this one's fine. And 4/3 goes with this up couple of letters there, so let's cross that off. For this one, this time around, the factoring has to happen in the lower left. It's not the last expression anymore. So things that multiply to negative 21 and add up to 4. 1 and 21 doesn't work. 3 and 7 does if we have negative 3 and positive 7. So a minus 3, a plus 7. That gives me an LCD that at least includes a minus 3 and a plus 7. And judging by the other denominators, that's actually going to do it because we have everything that they have already. So multiplying all my numerators by the LCD, so the a minus 30 gets multiplied by all of that. Next, the 5, and then the 2. And I'm going to do a plus and a negative 2 just so I don't have to worry about that negative later on. I've already got it built in there. Okay, going back and crossing a few things off. The a minus 3 and a plus 7 are gone. The a plus 7 in the middle is going to go away. And then these a minus 3s over on that last fraction also taking a hike. So what's left? We have an a minus 30. Up here we have a 5 distributed to a minus 3, so that's 5a minus 15. And then here we have a negative 2 being distributed, so negative 2a minus 14. Cleaning up the right side a bit, we have 5a minus 2a gives me a 3a, and my left side's going to be unchanged there. And then negative 15 minus 14 is negative 29. All right, so let me move my a's over to one side and my numbers over to the other. If I subtract 3a from a, I get negative 2a. Adding 30 over here gives me a 1. Dividing by the negative 2, we have a equals negative 1/2. If I plug that back in up here in the original, that's not going to give me undefined anywhere. There's no zeros in the denominator. So negative 1/2 is our answer. That's this SH right here that we can now cross out. Now we're off to number 4. So we got some good news and bad news on this one. Let's start with the good news. Nothing needs to be factored. We can pick out our LCD pretty easily. We're going to have the x minus 1 from one of these denominators and the x plus 4 from the other. And it doesn't really matter what order we write these in. So I'm going to multiply each of these by my LCD. And by the way, you could solve this by cross multiplying as well, but I'm going to just do it this way. So LCD times the x up here, and LCD times the 3 up in that other fraction. Back to my first fraction, the x plus 4's cancel. In the second fraction, it's the x minus 1's canceling. So we have x distributed to x minus 1. That's x squared minus 1x equals 3 distributed here gives us 3x plus 12. Now here's the bad news. This is a quadratic, no longer a linear equation like we ended up with on the last 3 problems. So we're going to want to get everything on one side here and possibly try to factor this. If not, it's quadratic formula time. So my x squared can stay where it is. The negative x, I'm going to subtract this 3x from there to get negative 4x. And then 12 comes over as a negative 12, leaving us with an equals 0 on the right. Now I'm going to factor what we have here. Things that multiply to negative 12 and add up to negative 4. 1 and 12 doesn't work. How about 2 and 6? That works if I have a positive 2 and a negative 6. So we have x plus 2, x minus 6. And if I zero out those factors, I'm going to get x equals negative 2 and positive 6. Now before I just go and accept these as my answers, I have to double check in the original. If I plug negative 2 in to both of these denominators, I don't get 0 for either of those. If I plug 6 in, 6 plus 4 and 6 minus 1 also don't give me 0 down there. So these are actually both good answers. And I can find those over here at the very end in this last box, which I will now cross off. For this next one, we've got another one that it's pretty easy to pick out the LCD for. Clearly we need a y plus 2 and a y minus 2 in order to be able to cancel out these denominators. So multiplying everything by my LCD, we've got the 6 times the LCD plus the 1 times the LCD equals, this one also gets multiplied by the LCD, so don't forget about that. So over back on the left, y plus 2's are canceling, as are the y minus 2's in the middle. And going back through and distributing, 6 distributed to y minus 2, that's 6y minus 12. Next up, we have a 1 times y plus 2, which is just y plus 2. And over here, this 1 isn't really making a difference. If we multiply out these two, we end up with y squared, and then we can use my a squared minus b squared shortcut since we have a plus b times a minus b here. So just square the 2 and stick a negative in there. So that's going to be minus 4. Now we have to get everything over on one side in order to factor this since we have a quadratic. I'm going to keep stuff over on the right side here. So this y squared isn't going anywhere, but I'm going to pretend it's on the left side when all is said and done. So we have a y squared. Well, actually, let me simplify this a little bit first. So we have a 7y minus 10 equals y squared minus 4. And now let me move everything over. No need to do everything in one step if I don't have to. So we've got the y squared. 7y is moving over here, so that's a negative 7y. We're adding 10 over to the side that has the y squared, so negative 4 plus 10 is a 6. And I'm going to write the equals 0 over on the right instead of the left because it just feels weird writing 0 equals. So numbers that multiplied is 6 and add up to negative 7. That would be 1 and 6 if they're both negative, so y minus 1, y minus 6. And then I can set those both equal to 0 and solve to get y equals positive 1 and positive 6. If I plug each of those back into the original, 1 and 6, neither of those are going to give me 0 in the denominator anywhere. So those are both acceptable answers. And I find both of those back here at the very beginning, this first box, getting crossed off. Here we go with number 6. This one looks innocent enough at first glance. It actually turns out to be a little more involved than you might think. It starts off nicely enough. Our LCD is going to have an n from our first denominator and this n minus 1 also. So multiplying everything by the LCD, we've got 3 times all that stuff, 2 times all that stuff, and that'll equal a 2 over here times all that stuff. Okay, the n's can cancel in the first fraction, n minus 1's cancel in the second. So far, nothing out of the ordinary here. Let's distribute now and see what we've got. So 3 distributed gives us 3n minus 3. Over here we have an n times 2, so plus 2n, that seems fine, equals, well, this is a little bit more, but we have a 2n being distributed essentially. So 2n times n is 2n squared. 2n times negative 1 is negative 2n. So already we see things are a little bit funny because not only do we have a squared term, but it's 2n squared, not just n squared. So we're thinking we're either going to need to do some factoring later on or AC method or something like that. But let's get everything on one side. In fact, let me clean up the left side a little first. So 3n and 2n gives me 5n. And then I've got negative 3 over there still, and nothing else is changing. Now let me move everything over to the side that has the squared term. So 2n squared, going to stay where it is, stay positive. I'm going to subtract 5n over here. So negative 2n minus 5n gives me a negative 7n. And then I'm going to add 3 over to the side that already has the 2n squared. So that's now a plus 3. And then instead of writing 0 equals, I'm going to write equals 0. Same thing, right? And at this point we see that I can't fix this a value problem here by just taking a 2 out. I've got to use my AC method. So AC value is going to be 2 times 3, that's 6. So I'm looking for factors of 6 that add up to negative 7. Negative 1 and negative 6 will do it. So just to review the AC method, I split this middle term up into those magic numbers with the n's attached to them. So this will be a negative n minus 6n that I'm replacing the negative 7n with. And now since I have 4 terms, I'm going to use factoring by grouping. So for my first 2 terms, I can factor an n out of that, leaving me with 2n minus 1. For the next 2 terms, I'll take a negative 3 out of those, leaving me again with 2n minus 1. My duplicate of 2n minus 1 comes out as a common factor, leaving n minus 3 as the other factor. And now I set each of these equal to 0 and solve. So if 2n minus 1 equals 0, if I add the 1 and then divide by 2, I get 1/2 for that n value. And then if n minus 3 is 0, 3 equals n as well. That'll give us a 0 in that one. Let me go back and check to make sure neither of these zero out my denominators. 1/2 is going to be fine. If I plug it in for this or this n, we're good. 3 also doesn't cause any problems up here. So these are both good answers. And I'm looking for 1/2 and 3. That's this IG box, so that's gone. So here we go with number 7. The LCD on this one, looking at my denominators, we have an x plus 3 and an x minus 5. So let's multiply everything by that to get rid of our denominators. So we have all this times this 2, all of this stuff times the x up here, and then all of this times the 3. And I'm going to make this a plus -3 when I do this, just so I don't have to worry about it later. All right, so these x plus 3s are canceling in that middle fraction. Over here it's the x minus 5s. And now it's time to multiply things out and clean things up. Before I distribute this 2, I'm actually going to FOIL this LCD out just so I can save myself a little bit of work down here. So up here we have x squared, and then -5x, 3x, and then -15. So that's a grand total of x squared minus 2x minus 15. Now I'm going to distribute this 2 to all of that stuff. So that's going to be 2x squared minus 4x minus 2 times 15 gives me 30. Moving on now to this other fraction, we have an x being distributed here. So that's going to be an x squared minus 5x. And then over here I'm distributing -3. So -3x minus 9. At this point, since I have a quadratic, I'm going to get everything over to one side and zero this thing out and pray that I can factor this. So let me subtract this x squared over to the left side. 2x squared minus x squared is just 1x squared. And now I have a -8x right here. If I add that over to the left side, -4x plus 8x gives me +4x. And then -30 plus 9 is going to be -21. And then we have a 0 on the other side. This definitely looks factorable. Factors of -21 that add up to 4. 1 and 21 doesn't work. 3 and 7 does. -3 and +7. So I'll write x plus 3, x, or actually -3 and, -3 +7. So x minus 3 and x plus 7. Yep. Setting each of those equal to 0 and solving, we have 3 and -7. And it's a good thing I didn't write x plus 3 here, because that would have given me a -3, which would have zeroed out one of my denominators. Fortunately, this is a +3. 3 plus 3 is okay. That's not 0. -7 doesn't give us any problems up there either. So those are our answers. -7 and +3, that's right here, this FR box. So let's cross that off and be on our way. On this problem, before I can go any further, I'm going to need to factor this lower right denominator to see if I can match some of the factors. So factors of 14 that add up to -9, that would be, let's see, 2 and 7 works if they're both negative. So d minus 2, d minus 7. And my LCD then will at least need to include that. And that also covers the first and the second fractions in terms of denominators. So let me just go ahead and multiply everything by this LCD now. So this 1 gets multiplied by the LCD, d gets multiplied by the LCD, and then this 5 up here also gets multiplied by all that. Now the fun part where I get to cross off things. D minus 7 is gone, D minus 2 is gone, and D minus 7 and D minus 2 both gone over there, which is awesome. Distributing out, we have a 1 times D minus 2. That's just D minus 2, so that's good enough. We have a D being distributed here, so that's D squared minus 7D. And then that's going to equal, well, just 5. Okay, let's get everything on one side and simplified here. So we have a D squared, we have a D and a -7D, that's going to be -6D. And then this -2, if I subtract this 5 over here to zero things out, that's going to be -7. And then equals 0. Factors of -7 that add up to -6. 1 and 7 works if I have +1 and -7. So D plus 1 and D minus 7 equals 0. Zeroing each of these out, we get D equals -1 and +7. Now let's double check. If I plug -1 in up here, that doesn't cause any problems. if I plug 7 in, 7 minus 7 is going to give me 0 in the denominator, which would make this undefined. So since 7 makes my original undefined, it's an extraneous root, a fake answer. I have to cross that off. I can't use it. And that means -1 is my only true answer. Finding that down below, I see that right here, so cross it off. And on to the last problem. All right, here we go, final boss battle. Taking a look at these denominators, I've got an x plus 1 and an x minus 3 for my LCD. Let's multiply everything by that. So I've got all that times the x minus 1, which I'll put in a parentheses just so I don't lose anything. All of this times the 6. I'm going to make this a plus and a -6, though, just to make sure I don't lose track of that negative sign later on. And then I'll multiply my whole LCD by this 3 here. So in my first fraction, the x plus 1s are canceling. Careful there, this -1 is different. Then we have these x minus 3s canceling. And now it's time to multiply things out. First fraction, I'm going to FOIL these out. So we have x squared minus 1x minus 3x, and then plus 3. Over here, this is going to be a -6 distributed to give us -6x, and then minus 6. And then for this last one, I'm going to FOIL this out up here before I distribute the 3. So I've got an x squared, a -3x, an x, and a -3, combining to give me a -2x in the middle there. So now I'm going to distribute 3 to this expression. That's going to be 3x squared minus 6x minus 9. And I'm going to clean this up and factor it as best I can. So on the left side, the x squared can stay where it is for the moment. -x and -3x is -4x, minus another 6x gives me a -10x. And then 3 and -6 combines to -3 over there. And then my whole right side I'm just going to bring down for the moment. Now I'm going to move everything over to one side. Just to keep my x squareds positive, I think I'll subtract everything over to the right side. So 3x squared minus 1x squared is 2x squared. And then -6x plus 10x is 4x. And then -9 plus 3 is -6. It looks like I can factor a 2 out of there. That leaves me with x squared plus 2x minus 3. And then factors of -3 that add up to 2. Well, 1 and 3 is it, and that works if we have -1 and +3. So the 2 is still there, or not. You could divide by it if you wanted, but we definitely have an x minus 1 and an x plus 3. Zeroing out those x factors, we've got x equals 1 and also -3, and I should have written equals 0 here. I'll do that in a later installment. So now, taking a look at my original, if I plug those in, they come close, but they don't actually zero out anything. 1 plus 1 is okay, -3 minus 3 is okay. So those are the answers, and we're ending up with this AM getting crossed off then. And now we're ready to go ahead and solve the puzzle. So now the riddle was, what sound did the sheep hear when her sister exploded? So we've got SI and S, I guess that's sis, like sister. And then we have a B, O, O. And then we have an M as the next letter, so that's boom. And then B, A, H is ba. Sis, boom, ba. So this is actually, I think, an old Johnny Carson joke from like 60 years ago or something. It's also supposed to be the sound like when a rocket explodes, the sis is the fuse going off, the boom is obviously the boom, and instead of ba, you have ah because of the people applauding and clapping. Maybe kind of a dated joke, but hey, there it is. So until next time, Mr. Sutton signing off.